So this is what I'm trying to build. I'm trying to build, was my idea. I'm trying to build an object like this that has keys like this. That has,
Excuse me, sir.
Yeah.
I can't record.
Did you pay the fee?
Sorry?
Did you not pay? You didn't pay the fee, the recording fee?
I paid you. Check your account.
Oh, okay. I'm sorry. Sometimes I don't check.
Me either, John.
Sule? Okay.
Yeah.
Sorry. Sule. There you are. Okay.
Thank you.
Yeah. Okay. So I'm trying to build something like this. This is where my head goes. And this to me looks a lot like this. The word one, right? Where we had the word the show up 5 times. And the word show up 7 times, right? We asked if the word, we started with something like this, an empty object. We checked to see if the word already existed. If it didn't, we created the key and we started it at 1. And I'm doing the same thing over here. I'm checking to see if in this empty array, if the genre already exists based on the movies, right? If the genre already exists. So I go through each of the movies, I can look up each of what those genre names are. I can even look up the genre numbers. These could be genre numbers for all I care. They don't even have to be names, right? They could just be numbers. And then when I'm printing them out, I just go grab the name from the other object, right? I check to see if that genre exists. If it does, then I take it, action, right? Then I grab this object and I say object genre dot push movie, right? And that'll add a new movie onto this array if it exists. If it doesn't exist, I say object. And again, this is very diluted. Like you can't just copy and paste this code. This is just a thought, an approach. I say genre equals empty array with my movie in it, right? So this is what I do when it already exists, i.e. there has been another movie with that genre that I found going through all my movies. Or if this is the first time I've encountered a movie in this genre, then I create a new key and set a new value for it. And that is an empty array with the movie inside, or a new array, right? Because it would otherwise, if we had like the third, for example, the third one, action, adventure, I don't know what the next one is. Let's pretend drama. Drama does not exist. So the key will be drama. Now, where is that coming from? That's in a variable, so we could put it as a variable, right? So it'd be drama equals the new movie. And so these are movie objects that contain all the information about movies. Once you have this object, all you need to do is iterate over this object with a for in loop to grab the key and the values. And it goes key, genre, values, movie, 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 movie. Key, genre, values, movie, movie, movie. Does this approach make sense?
Yeah.
I see a couple head nods. Yeah. Okay. So you have all the information. So this is, in my opinion, this is what you're trying to build. This is what would be a really great thing to try to build. Okay, so don't try to think about iterating and printing stuff out immediately. Instead, try to reshape the data, in my opinion. This is my opinion. In my opinion, for me, I feel like it's easier to try to shape the data into something that I want and then loop over that new structure and print it out. So this is, I would rather try to print this out than try to print out two separate objects, kind of like going back and forth and like doing some crazy stuff. I would rather just like reshape the data into something like this and then print this out. Because this, to me, seems like this would be easy to print out. If I just gave you this, if I gave you just an array, an object of genres and movies, genres and movies, genres and movies, and said, print this out, you'd be able to do that no problem, I think. Okay, so that's my big tip. Try to reshape the data into something. Now, it doesn't have to be this. If your mind goes somewhere else, that's fine too. Okay, but try to reshape the data into something that makes a little bit more sense for printing out, for managing anything, actually. Okay.
Sir, I have a question. So, for this exercise, what I need to do is not to get the movies from the APIs for search, but to get some movies to display, and then when I search it, I can find it in some different genres, right?
Yeah. Yeah. So you're only getting two endpoints, right? You're only getting from the genres.
Now I understand what I need to do.
And trending, right? So you're making one call to each of these one time, right? So you're only making two calls to the API when the page loads, one to genres and one to trending, and that's it. Now you have all your movies and you have all your genres. Now you take them and you try to build something like this.
Yeah, okay. I got it. All right, thanks.
You're welcome. Okay. You want to see what we're doing next week? This is what I've been working on. And then I'll lecture. I think we're going to do something like this. And then you click on the thing, you click on the location, and it shows you start at home, and it drops the pin for that location and puts a little flag over it. What do you think? Do you want to do that? Or do you want to do this? Or do you want to do local weather? Your choice. Maps or weather?
Maps.
Maps? Okay. Maps can be complicated because maps have like longitude. Well, weather has longitude and latitude too. But I will try to take the complicated parts and give them to you and have you build the other stuff around it, right? So I will provide lots of support around the complicated parts. But I think it's pretty cool that we can do this. Like, it's literally like a map, just like you would expect. And you can like trace routes, you can get traffic, you can do all sorts of stuff. Yeah.
Is all of the map data pulled from an API still? Like all the visual data too?
Yeah, this is a weird one. You can get the visual data from an API, but the way we're going to do it is we're not pulling the data from an API. We're going to use a library, which does the API work for us for the map itself. We just say where we want the map centered, right? I have the map centered at my address. Oh, and along with this, I'm also going to teach you how to get someone's location from the browser. You know how the browsers pop up and say like, hey, do you want to allow this website to use your location? I'll show you how to do that. And we'll use that So when you open the page, it automatically centers on your current location. And then I'm using an API here to get locations close by, to generate this list of like sushi places that are in the area. By the way, sushi, I like it. So there is an API call that it's being made. I'm passing this string to the API. It's giving me locations close by that match. And then I take those latitude and longitudes, and the idea here, I have to finish this today. The idea here is to plot them on the map and drop little markers onto them based on the ones you click on. Yeah, you can even, and again, I can even like ask for, then say, here's my starting location, here's my ending location, give me directions. And it would say, here's a set of directions with like all these different stopping points and like changing directions. It's really cool. We're not going to do that much though, but I just wanted to show you something because I don't know. I think this stuff is kind of cool. You can do some really cool things. 2 Mile Road. Okay, so yeah, this is what we're doing next week, but next week. Okay, today we've got some other stuff that I need to talk about. Today we're going to talk about GitHub. Okay, so we're going to do another session on Git. So let us start that. We are at lesson 9, pushing and pulling. Okay, so we're going to be talking about essentially remote repositories. So far with Git, we have been working just locally, right? Everything has been local to our computer, and which is fine. Like it works really well. But you might be thinking like, okay, but John said that we use this a lot for collaboration. How does this work? How does Git work with collaboration? How do we collaborate with Git? Okay, and the idea, one of the best approaches that we have is putting together a remote repository. Generally, a remote repository. Now, something I mentioned is that Git is not centralized. Okay, there is no centralized place that we all need to go and get the information from. As long as I have a copy, we're able to rebuild the copy. And I mentioned this yesterday. We were talking about normalize. I pulled in the normalized data, and I made a bunch of changes, and then I just undid all my changes and reset it back to exactly the pristine copy, right? Because someone had a copy of it. Now, this someone, as long as one person has a copy, we're good. The problem is me having a copy and me being a human who closes his computer, whose battery runs out, right? That's not very useful to everyone else on my team. What we need is a computer that exists that doesn't turn off, where we can access all the time, right? It's kind of like the idea of the web. Our websites want to live. Yes, our websites can live on our computer. They can be on the internet being hosted from our personal home computer. But the problem is when that computer turns off, now the website turns off. And that's the same idea with Git and these and distributed repositories, is that yes, we're collaborating. And so you and you and you have repositories on your computer for the project. But the problem is sometimes your computer turns off, sometimes your computer turns off. So none of these are a place that we want to be collaborating to, because we can't trust that it's always available. We want something that has high availability, that's always available for us to move our changes to and to take changes from. Because if we're all working together, you're making changes, you're making changes, you're making changes, we all need to be able to put our changes somewhere and pull down each other's changes. Okay, grab those changes from that one place. Now that's not, it kind of sounds like it's centralized, but it's not really. We're just all agreeing that, you know what, maybe we should make this repository the main place that we all keep our stuff. We're all going to have our own separate repositories locally on our machines, but when we're done working at the end of the day, we should probably copy our changes up to this other location that everyone can always access all the time. That way, when I close my computer, my changes don't only exist on my computer and you can't access them anymore. Okay, and this is the concept behind GitHub. They have a really cute little 3-minute video trying to explain what GitHub is, and I liked it, so we're gonna watch it together, if that's okay with you, to maybe give you a better idea of what GitHub is. There's a lot of reading for this weekend too, a lot of documentation to go through for GitHub.
Those readings are for after the assignment, right?
No.
For assignment 1.
Well, I mean, like, yep.
Okay.
Yeah, I'm expecting you to do some of this stuff for assignment 1, but your assignment 1's not due till Tuesday end of day, and we're Friday today. Okay. So, do some math. That's Friday, Saturday, Sunday, Monday, Tuesday. That's 5 days. Okay. So we're going to look at, where is it? There we go. So you can't hear sound yet. I'm going to stop share and then restart my share here. Stop, share computer sound. Optimize screen for sharing video clips. Okay, try that.
Okay, what is GitHub?
Here.
Well, GitHub is a platform that helps people solve problems by building software together. So, how does it work? This is Sam. Sam works on tractors all day, but not in the way you might be thinking.
Here.
She builds the software that helps make tractors more efficient. And she does this on GitHub with the help of her team, Vijay, Melinda, and Mike. Now, even though they all work on the same project, Sam and her team don't all work in the same part of the world. This is Eddie. Eddie also works on tractors all day, except he actually works on the tractors all day. And this is the Harvester L700. It's the latest flagship in the company's fleet of tractors. It's full of sensors and processors that produce a ton of diagnostic data. Eddie has a great idea for how farmers might share their data and improve their harvests. So Eddie opens an issue on GitHub. Issues are discussion threads where people can report bugs, request features, or even just ask questions. Sam is the first one on her team to see Eddie's issue, and she thinks that Vijay would be the best person to start the job. And here's where we get into the nuts and bolts. Eddie isn't the only person using the Harvester L700. All over the world, other tractors are collecting moisture data, and they need to keep running smoothly even while Vijay is working on the new features. He needs a dedicated place to experiment so none of his changes end up on the farm before they're ready. So he creates a branch of the code, an alternate timeline where he can safely make changes to the software. Now he's ready to start writing the new feature. GitHub tracks Vijay's changes and saves snapshots of his progress. When he's ready to collaborate on the changes with his team, he opens a pull request on GitHub. Pull requests let you show others the changes you're proposing so they can review and discuss them. This means Vijay's teammates can help with roadblocks and even make improvements. On GitHub, everyone has a copy of the project. So if Melinda has an idea for something that will help make Vijay's work even better, she can add it to the branch herself. GitHub keeps keeps a record of everyone's contributions and feedback in the pull request, alongside relevant messages from the team's other systems. Once the team has signed off on the changes, VJ can incorporate the new code into the project. The new feature will be available to everyone as soon as he merges it in. Now farmers everywhere can all benefit from Eddie's great idea. But this is really only the beginning of the story. Because GitHub is the largest community of developers in the world, with millions of people sharing their projects, Eddie's idea could end up helping people in unimaginable ways. What kinds of problems are you trying to solve? Whether you're an engineer, a code enthusiast, or even a farmer trying to harvest grain, software touches every corner of our lives. GitHub is where people build that software. It's how they build software. Together.
How was that? Could you hear it? Yeah? I couldn't hear anything. I've already seen it. I don't know how the sharing sound works, but. So I hope this gives you, when I was watching that, I'm like, oh, hey, we just talked about branching. Oh, hey, we just talked about merging, right? We haven't talked about pull requests because we haven't talked about GitHub yet. But the idea behind GitHub is it gives us a platform for collaboration. We can work without it, but it adds a lot of features and value to it. For example, communication, pull requests, which don't exist otherwise. That's kind of like a GitHub thing. There's a lot of additional value that GitHub adds to a central, again, I say centralized, it's not a centralized place, but it kind of is like a centralized place where we keep our code. So that's what we're going to learn about today, okay? So we should start by creating GitHub accounts, okay? If you don't have a GitHub account, you should be going to www. I don't even think you need to do the www, github.com. Now, this is going to be your GitHub account. I mean, you can create another account later, but this is probably going to be your GitHub account forever, maybe, right? Doesn't have to be forever. You can always restart just like anything else and create another account, but pick a good username, pick a good photo, okay? Your GitHub account is something that you're going to give out to your employers at some point when you're applying for jobs, because this is where your projects are going to exist, okay? So start by signing up. It's free. I'll give you a couple moments to do that. And once you're done, we'll go move ahead. So github.com. I guess I'll post this in the course. Are we all done? Cool. I'm just removing my passwords here. I hate it having multiple password managers. One's trying to override the other one. Okay, so once you've created your account, they'll probably ask you for like an email check or some authorization. That's pretty normal. Okay, so this is where when we're done, not when we're done, but that frequently throughout the day, although we are making snapshots on our machine, we're also going to push these snapshots up to GitHub. And GitHub is going to have all of the history. It's going to have the same repository that we have on our machine. So if you do get frustrated one day and decide to throw your computer across the room and smash it into a wall, and your computer stops working, you can go to the store, pick up a brand new computer, go to your GitHub account and pull down all your projects. So even they exist on your computer, but this is a centralized place that they're backed up to. That's not the purpose necessarily of GitHub. The purpose of GitHub is really for collaboration and open sourcing, okay? Because we're able to work with other people our colleagues, other people around the planet on anything. This is kind of the place for open source software, okay? And as we start to explore it, you'll kind of see how it works. So the first thing that we're going to want to do when we're putting a repository on GitHub, let me just make sure I'm in. Watch the videos. So GitHub, one thing I just want to highlight is GitHub is not the only player in this game. They're probably the biggest and they've been around the longest. Does anyone know who owns GitHub? This was a big story last year.
Microsoft.
Yeah, Microsoft. So Microsoft bought GitHub last year, and that was a big thing because for years and years and years, Microsoft has been known as not an open source software company, right? They make software to sell for profit, and so they don't do open source. And then VS Code came out, and VS Code is open source. And there's a bunch of stuff that they're starting to develop that's open source, including this terminal program, which is pretty awesome. And then they decided to buy GitHub. And that was a big thing because a lot of people are like, oh, I can't believe Microsoft is buying GitHub. They're not the only player in the game. There's other companies that are very similar. One of them is called GitLab. This is one that I used to use as well. Okay, super similar as GitHub, same idea. It's got collaboration tools. It's got way more stuff. Both GitHub and GitLab have way more stuff in them than you can possibly imagine right now. We have one called Bitbucket, which you might use in the back end. Bitbucket is pretty good. Just again, another company, I think, who owns, I don't know who owns Bitbucket. I think Amazon also has their own as well. Their own type of Git collab or source control. These are source control collaboration tools. They don't only do Git. They started as only Git, but they've expanded their offerings to support some other source control as well, such as Mercurial and SVN. But again, most people are using Git anyhow. Okay. But in this course, because GitHub is by far the biggest, they have the biggest market share, and very likely you will be using it. Anyone is hosting their stuff on GitHub. So we're going to start by using GitHub to create a repository. Okay. So if you go to your home page, you probably landed on it. Okay, it probably looks like this. It's got no picture for you. Okay. It just has your repositories here. Okay, I've got 63 repositories. You have 0, that's okay. Over time, it'll start to grow, okay? If you click on repositories, or if you're logged in and you simply just go to github.com, okay, well, either one of the two, you're essentially looking for the word repositories with the button new beside it, okay? So you can either click on your picture at the top right and click on your repositories. Okay. And then you have a green button called New there, or if you're on the other page that I showed you, there's a green button called New there. You're going to hit that green button. Okay. And we have this repository that we should be using right now if we haven't been already. I probably asked you to start committing all your stuff, right? So we've been working on this movie project for the past day or so, right? So let's create a repository on GitHub for that. Even if you already have a repository on your computer, that's fine. I'm going to show you two different methods. Okay. So even if you have already created a repository on your computer for this movie thing that we've been doing, that we talked about this morning, the one that we're going to look at the end of the day, that's fine. Okay. We're going to we need to create a repository on GitHub as well. Okay. We need to create one on GitHub, absolutely, for sure. Okay. So I'm going to call it, we're going to give it a name. They're memorable, short and memorable. Okay. So let's call it, I like to give them fun names. Movie Madness. Okay. So it's going to be Movie Madness. You don't have to put a description if you don't want to. You can make it public. Anyone can see it, or private. Only you can see it and people that you choose. Up to you. Okay. This never used to be an option. Okay. It used to be public only. Private was for paying people, but now anyone can have private repositories. Initialize this repository with a README. We don't need that. Add a get ignore. We don't need that. We're going to add our own. Add a license. Don't worry about that. So pretty much we don't want any of these checked. And we're going to, and if you want to put a description, you can. Okay, and we're going to click create repository. Oops. Okay, so we have a repository created, and it's got some information for us. It's got 3 different ways of finishing our setup. Create a new repository on the command line, push an existing repository from the command line, or import. So I'm going to show you 2 of these different ways. We're not going to cover import. We're going to cover this one, and we're going to cover this one. So our options are the following. Usually I would pick option 1 when I have not yet started my project, i.e., this is the first step to starting my project. Okay, that's when I would pick option 1. So option 1, I do not do this echo #movie madness readme thing. Okay, you can do it. That's fine. Typically option 1 looks like this for me. So I'll open my terminal or your git bash. And we start with a git clone. We've created a repository on GitHub. Now we're going to clone it down to our computer. It has nothing in it, but it has settings in it. Okay, so it exists and it has some settings in it. So that's what we're going to go, that's why we would clone it. Okay, so it says that right here. Oh, sorry. Oh, no, it doesn't say that at all, but I would do that. I would do it anyways. Okay. So I guess we've got multiple ways of doing this. Git clone moviemadness.git. So this URL up here or the URL up here, okay, both are fine. Okay, you can either copy and paste this or copy and paste this. They will go to the same place. And we hit enter. Git clone. It's just like a regular git clone. Now, you appear to have cloned an empty repository. Yes, this is true, but that's totally fine. Now I can go into Movie Madness and it is now a repository. I do not have to do a git init on it because the repository was already created by GitHub. All I did was I copied the information down, just like I copied normalize down yesterday. The only difference between normalize and this is this doesn't have anything in it yet, but it is a Git repository. It's ready. It is ready for me to start adding files to and making commits. Okay, so it's ready. So I started adding a file. So that's method one. Method two. I already have a repository locally on my computer, or I want to create a repository locally on my computer. Let me go to the Movie Madness thing that we're working on today, because now I gave it a name. Okay, because I don't think for me that's a Git repository. I don't think I've been tracking my work. Bad John. So let's go over there. So that's in C mount C A-N-Z. MIT. I think it might be this one. I don't know. But this is one. This is a directory for a solution. I don't have, it's not Gitified. Okay, so it's not initialized as a Git repository yet. Okay, so let's pretend that I don't do the Git clone thing because I already have files. I've already been working on my project. I already have files locally on my computer. I don't want to Git clone an empty repository and start working on that. Okay. That's unfortunate. Okay. I don't want to Git clone an empty repository and start working on that. I want to use an existing files on my computer. So I will go to the project and I will initialize it with Git. Git init dot or Git. Okay. So now this is a repository locally on my computer. I need to match it up with that repository on Git. I need to make that connection. I need to tell it, oh, by the way, I created this repository on Git. That's where you're connected to. That's your connection, okay? Because it doesn't know that yet. It doesn't have any connection, and Git doesn't have any connection either. We have to set those two up, okay? We have to make those two aware of each other. So this is a local repository. I'm going to do my basic stuff, okay? The adds, the commits, those things, the resets, those don't have any effect on GitHub. Okay. So we'll do git add dot git commit -m. Oops, lots of uncommitted work. Okay, so I committed a bunch of stuff. They still don't know it about each other yet. That doesn't tell them about each other. Here is how they learn about each other. There is a new command. So one way is to clone an existing one. If we clone an existing one, that information comes down with the previous that this information that we're going to type in is already set up for us. That's why when I say we're cloning an empty repository, but actually we're cloning some settings, these are the settings I'm talking about. But since we're not cloning it, we're gonna, and instead we're doing it manually, we have to add these by hand, okay? And it's really important to understand these settings because this method is very common, okay, doing it manually. So now we have to tell it about this Git repository that we set up for it. Git remote, okay? GitHub is going to be considered a remote repository, not a local repository, right? This is a local repository. It's a repository that exists locally on our computer. We are going to set up a remote repository, okay? And so we need to do, I think it's, actually the information is in here, okay? Git remote add, okay? And you can actually see it right here. So it says, essentially what this first piece is, these first 4 lines is add files. This is saying, it's saying specifically, so like, or push an existing repository. So this is the existing repository, okay? Push an existing repository. We need to git remote add. So we're doing git remote add, and then we have to tell it the origin. And the origin is the origin location to match it to. So we're adding into remote. The origin is GitHub. Not just GitHub, our specific URL for this repository on GitHub, right? This URL or this URL. Okay, it's already here for us. Git remote add origin. Okay, and this will create a connection from this local repository to this remote repository. And we hit enter. And there we go. We are now connected. Now if I come over here and I refresh this page, nothing happens. Okay. Just like everything else in Git, all of these processes are very manual, right? It doesn't automatically take snapshots. It doesn't even automatically track files. We have to do all that stuff manually. And so we're going to do that manually. We have to push our changes up to GitHub, push our repository up to GitHub. And the command for that is git push, okay? So there's a command right here, git push -u origin master, okay? This -u origin master is a one-time command that you have to run right at the beginning. If you don't include these last 3 pieces, -u origin master, every time you attempt to do what we call a push, it will ask you, where do you want to push it to? Okay, and I know it sounds crazy, but you should know where I want to push it to because I told you you're remote. There can be more places inside of here. Branches. There can be branches, right? We know we can create branches. Master is the master branch. When we push it, it's essentially asking us which branch do we want to push it to and which remote do we want to push it to. You can have multiple remotes. Don't worry about that now. Trust me, the first time you run this command, just run it the way it's posted. And then after that, all we have to do is write git push. So run it like this, and this will take our changes and push them up to GitHub. All of our code, not just our changes, all of our code, our entire repository, all of our logs, our commits, our files, our changes, everything. It doesn't push them, it copies them up. So we're gonna run this. And it prompts you for your username because it needs to authenticate. Like, why should I let you copy these files up? Who are you? Only you John should have access to John's repository, or someone who John has authorized. So it's going to prompt you for your username. And gotta go get that. And my password. And it's going to do a little bit of magic. And it says, branch master locally has been set up to track the remote branch master from origin. Origin being GitHub. Okay. And now what I've done is I've created a master branch locally, which is attached to the master branch of GitHub. Okay. And if we come back to GitHub and we refresh this page, we now see all of my code, my commit message, my one commit, my one branch, one contributor, the changes that have been made, the actual code that's in the application, everything. Okay.
Question.
Yeah.
Do we have to add the README? I noticed that you didn't. It's okay, right?
Nope. Nope, you don't have to. They're just saying add some files, essentially. If you don't add a README, you don't get anything here. The README gives you that like piece of stuff at the bottom here. That's what the README does. Generally, projects will have some sort of README, but we haven't really talked about that. But no, for this course, no. And it's not required, right? I don't have a README and it works. No problem. Okay. So that is push. The one that is setting up a repository and pushing to it. Okay. So pretty much the additional step that you're going to add now is this. New version. So we're going to make a small change here. Oh, yeah, don't like that. Okay. So I made a small change here. Here's our new workflow. On top of creating branches and everything else, we now added it. I didn't create a branch for that, but okay, let's pretend, created a branch, did my changes, merged it back. Now I have some changes. I took away an empty line. Git add dot, git commit -m, add some new changes. Now, you better commit message, right? All that stuff. That's not our focus right now. Now, that was our workflow before. Our workflow now also includes this. Git push. It should remember your username. It shouldn't be prompting you for your username every time. I'd be surprised. I'm surprised that it's asking me again. Okay. And so that is our new workflow, is we push every time. It doesn't, you don't have to push every time that you commit, but I almost do. Okay. And if we come back here, we refresh, we see 2 commits, right? We can look at the commits, 1, 2. So when we're asking, and this question has been asked me several times, like, how are you going to evaluate our work? I can see everything that you've done, right? I can see all your commits. I can see your commit messages. I can see what's in your commits. The green means added, right? Red means removed. Let's see what I removed, right? Side-by-side comparison. I removed this line of code, okay? I can do a side-by-side comparison. I can do all of that stuff. So I can see all the work that you've been doing. I can't see the commands you've been running, but again, the commands to me aren't really that important. It's the end result that's important. Okay, if you screw up in your commands, whatever, right? Type them in again. And I don't require you to memorize them. You will want to memorize them because if you don't, it's going to slow you down tremendously. So it shows me everything. So this is how I'm going to evaluate you, is by saying, give me access, make me a collaborator on your private repository, or send me your public repository URL. Now, how do we, so if there are multiple people working on this, how does this work with multiple people? Okay, because that's, again, this is the concept of Git, is collaboration tool. Or you threw your computer against the wall, it's smashed, you want to get these things down. You want to get new changes down. Someone else has been working on this, okay, you want to get these new changes down. I'll show you how to do that. So I'm going to open up a new tab here, and this new tab is going to represent a different individual. Okay, so I'm going to be operating as person 1 and person 2. And you can do this from one computer. It's no big deal. It doesn't care about computers. Okay, all GitHub cares about is changes, just changes. So we're going to go over here, and we're going to do I think I already have something set up to track this, right? Movie Madness. Remember, I cloned it earlier. Movie Madness. So we're going to go into Movie Madness. And there's a really interesting thing going on here. I have changes already in Movie Madness that I made. But the big difference is I didn't push these ones up, right? So while someone else was busy committing the entire repository, person 2, cloned the repository and added a file. And I'm like sweating bullets, like, oh shit, oh, John already had this repository. He probably committed the whole thing. What did I do? Did I screw something up? Can I get myself out of this? And the answer is always yes. You can always get yourself out of this. So to pull down new changes, right, to grab things from Git, we do a command called git pull. As long as we set up the remote, right? We have to set up the remote first because it needs to know that it needs to have that connection. If it doesn't have the connection, it doesn't know where to pull from. It's looking for a remote repository somewhere. Git pull means pull down the most recent updates from the remote repository. Now, what is considered recent? Recent is, well, look at my history and look at the GitHub's history and catch up all those changes, right? So we're going to pull down all the changes that we don't have. And we're going to encounter some pretty weird stuff because I have changes on my machine that Git is not expecting, which is very common, right? Remember, we're 2 developers working separately. And, jeez. There's a better way to manage this. It's just a little bit too much for one lesson. So what does Git have to say? What does Git have to say about this? Git has to say, No. You're asking me, you have some history. The repository has totally different history. Not going to do it. Okay. I refuse to merge these unrelated histories. So if we look at our Git status or our files, nothing got pulled down, nothing changed. But our status changed. It says your branch, my local branch, and origin master. Origin master is the master branch on origin being GitHub. So, and the thing on the repo on GitHub have diverged. We have different commits, respectively. Use git pull to merge the remote branch into yours. I cannot do it, okay? So how am I going to get myself out of this mess? I can back up the train. Can't go back anymore. Or I can, no. Huh. Interesting. I can always get clone it again. We can do that. You should be able to back up things, but so there is a problem sometimes, right? Which is one of the challenges with git reset. Git reset, you don't want to, so you don't want to make changes to history, to things that have happened in the past, and then push that to GitHub. Okay, so when we're doing git reset, we don't want to back things up and then push them up to GitHub, because that's going to screw up everyone else who's working on it. You only ever want to move forward. Okay, so git reset is used fairly sparingly. Now that I'm introducing GitHub, I'll tell you git reset, the thing that we learned yesterday, is used quite sparingly. Okay, and we don't want to push time. We don't want to mess up time for everyone else. Okay, if we push these changes to GitHub, if we reverse time, we push those changes to GitHub, we're going to mess everyone's timeline up, and we don't want to do that. Okay, so instead what I'm just going to do is I'm just going to delete this directory, or I can clone it again, right? I can go up here, and we know how to do this. I can say git clone Movie Madness into Movie Madness 2. It'll create a new directory, Movie Madness 2. Oh my goodness, are you serious? I have a feeling this is going to be a recurring theme. Okay. Movie Madness 2. So I cloned all the changes. So let's pretend we're two developers and we're working simultaneously. So I'm changing index 2. So let's code dot. It'll open a new VS Code. So that one space is taken away. So I'm doing some other stuff. Okay, I had a bunch of spaces. Git add dot, git commit dash m. Git push, right? And it prompts me for my username because it's broken. I have a feeling yours won't do this.
Yeah, mine only asked for once.
Yeah, I think it might be a setting I have to turn on here. Okay, so I pushed it. Now this is person 2. Person 1 wants to get those changes. Git pull. It pulls them in and it automatically merges. Sometimes it can't automatically merge, right? Sometimes I have changes. So let's look at a couple different scenarios. This one was an easy one. This one was I am simply behind, right? Person 1 is simply missing some history, right? It's not fully up to date. That one was easy. We just took the extra stuff and we attached it right on. No problem. But sometimes, again, this is just like branching, right? Sometimes when we branch off and one timeline moves forward and the other one stays still. And that one's really easy. We could just merge, no problem. But sometimes timelines diverge, right? We create 2 branches and they both start moving forward, right? I'm programming and you're programming. So person 1 is going to do some programming. I think I have 2 open here. Yeah, I do. Okay, cool. Okay. Person 1 is going to do some programming. A little bit of programming here. Okay, and person 2 is going to do some programming. Let's do it on a different file, shall we? Let's do it in this JS file. Okay, so person 1 and person 2 have changes. Get status, person 1 changed index.html. Get add done, get commit. Change. Okay, I'm not going to push yet. And I'm going to commit over here, get status, JavaScript file. Yeah, cool. Okay, get add dot, get commit -m. Changes. Okay, so GitHub does not have the changes to this JavaScript file, and it also does not have the changes to this index file that I just made. It has neither of them. So this is, pretend we've been working all day on these complicated changes. Who pushes first? How does this work when I push my changes and then you push your changes? Let's find out. So person 1 is going to push their changes first. Get push. And GitHub will happily accept them. This is going to drive me crazy. Okay. Git happily accepts it. It says, yes, those are changes I did not have. And it is easy for me just to take those changes and stack them on top. No problem. Person 2 comes along and says, okay, I want to push my changes now. The problem is person 2, it's not GitHub, if we go get status, your branch is ahead of origin master by 1 commit, use git push. Okay, no problem. Git push. It says, failed. Updates were rejected because the remote contains work that you do not have locally, right? It has this work that I don't have locally that changes to index.html. Then it says, this is usually caused by another repository pushing to the same reference, origin, master, the same repository. You may first want to integrate the remote changes, i.e. git pull, before pushing again. So they're saying, we on our side, GitHub, we cannot manage this merge for you. If there is, so there's some changes on here that you don't have and you don't know about. And we can't just take your stuff and just attach it to the end because that might break things. So what we recommend doing is instead taking the changes down, seeing how they fit, seeing if there's any conflicts, and then pushing. So this is very common. So we do a git pull. And it is a merge, okay? Because there are changes. It's not a fast forward. It's not just a simple, you were stopped in time, things kept moving forward, and we're just going to move it on. But it's also not a merge conflict. It's a regular, just a regular merge where this changed, these files changed, and these files changed, but we know we can resolve it really, Git can resolve that for us really easily because one was one file, one was a totally different file, resolve the changes, no problem. So merge message pops up, yeah, no problem. We're going to merge the new incoming files in, save, close, and merge made by the recursive strategy. And that's Git, that's the third strategy. There's fast forward, merge conflict, and recursive. Recursive is Git managed for us. Fast forward is Git managed for us. Merge conflict, we manage ourselves. So we've incorporated these changes. We've determined how they should be incorporated if there was a merge conflict or whatever. So we've done all the work. Now we're no longer behind the changes that GitHub has. We're ahead. We've pulled in stuff and we have new stuff to push. Now we can push. Oh, come on. And the push finishes. So this was two people working simultaneously. And this is how two people can work simultaneously on a project that we can. And so now GitHub, now it's going to all show the commits as Jonathan, but it wouldn't necessarily, right? If there was someone else working, it'd say person one, person two, person one, person two, right? It would identify who made those commits. But this is exactly how the workflow goes, except we often make branches because this master branch is pristine. Okay. So here is what I'm asking you to do today and this weekend, and for this project, for this assignment, I am asking you to create a GitHub repository and push your changes to it. All this stuff with respect to merge conflicts and pulling, you're not going to do any pulling. You're only going to be pushing today. We're going to keep stuff because I know this stuff is not easy. We just added a whole nother level. And with this level, I'm saying, oh, well, this is just a merge conflict. This is just a blah. This is just a blah. But yeah, we just learned about that yesterday. And I expect you to be experts at it? No. We're going to keep practicing this, okay? I do expect you to create a repo and push to that repo. That is it. Okay, and one more little tweak that I want you to make. Okay. There's a link here that says do this. Let's do this together. So I want all of your changes to be no fast forward. So, wait, company policies, no version for merge commits. Okay, yeah. So this is what you're going to do. You're going to run this simple command that I'm going to post in Discord or Zoom. I'll do it Discord. This one command. git config -- global merge.ff, no. This stops fast forward merges, okay? This prevents fast forward merges. And the reason why is because what it allows me to do is it allows me to see your branching. If you don't do this, I cannot see your branching. So I'm asking you, as part of our assignment, which you'll see later today, I'm asking you to create branches. And then when you're done, merge those branches back in. If you do not create branches, if you don't do this, I won't be able to see that creation of branches. This allows me to see that. Okay. If I can't see your creation of branches, I assume you didn't do any branches. Okay.
When do we put that in?
Do it right now. Do it right now, one time only. Yeah, just like paste, enter, done. There you go. You're good. You've got your it's a one-time shot, and then it'll modify your configuration. Okay.
John, before you
Yeah.
proceed, I have a question.
Yep.
So I have like 2 branches for sorry, for my local repo, and I pushed this on GitHub, and it's only showing 1 branch. So
you pushed. What did you push? You just pushed, or did you push the branch?
let me see.
Yeah. So by default, it only pushes master. If you want to push a specific branch, you have to say git push origin branch name. So like, for example, and again, this is a little bit outside the context, but since you're asking me, if I have a branch here, git branch something, git checkout something. If I want to push this branch something to GitHub, I have to say git push origin something. And then it's going to ask you for your username.
So by default, it only pushes the master branch.
Yep, because that's what it's set up to track. Yeah. If you want to push other branches, so now it said, okay, I've now pushed your branch. I don't expect you to do that. Not in this course at all. Okay, this is just additional information. And now when I refresh this, 2 branches. So you can see my default branch, which is master, my other branches, okay? And then other people can pull those branches down and work on those branches too. So if you're on a team that is working on a feature, which is very common in a big project, we've got teams working on features. So we have 10 teams, we're all working on one project, 100 people working on one project, not even joking, 100 people working on one project, teams of 10, each team is working on a feature. So a branch for each feature, and all that team is working on that one branch. So someone starts by getting it started, pushing that one branch, and now everyone's connected to that one branch, pushing and pulling to this one branch. Okay, because you can push and pull to specific branches. We're just pushing and pulling to master. That's the easiest thing to learn. That's the best place to start. Just one branch. We're all just pushing and pulling to the same place. But technically we can be pushing and pulling to whatever, to any branch. Okay. So, but don't worry about that. Yeah, you have to push specific branches.
But we only push the masters to GitHub. How are you going to be able to see if we are like merging branches?
Well, like, didn't you I just pushed the something branch, right? I can push other branches.
Yeah. I mean, you said in your assignment you're going to check if,
because of the merge commit. When you do a branch and you do some stuff on your branch and then you merge it back into master, like what we did yesterday, right? It creates a merge commit. No fast forward forces a merge commit to happen. So I can actually see the history of you creating the branch, the work you did on that branch, and then you merging it back. If you do a fast forward, I can't see that history. It just looks like you did it all on master, right?
Oh,
So I want to see that history. So I want to know fast forward. Remember, I mentioned there's 3 different types of merging. There's fast forward, recursive, and merge conflict. I'm eliminating 1. So now there's only 2, recursive and merge conflict. So most of your stuff is going to be recursive. Some of your stuff. You probably won't encounter any merge conflict. In our exercise tonight, I am going to ask you to do some of this stuff. Again, very like get stepwise stuff. Commit to this repository, create a new directory, clone it, pull it down. So there's going to be some git pushing and git pulling. Okay. The reason why I'm giving you this extra weekend for the assignments is because we have all this additional stuff that we need to manage on top of writing code. So on top of writing code, I need you to be pushing your code and committing and pushing to the Git repository. So you got a lot of stuff to do. Okay, but you have today. Well, I'm not giving it to you yet. You've got something else to work on. You've got today, tonight, a couple hours tonight, tomorrow, Sunday, all day Monday, all day Tuesday until 3:15. So you've got lots of time. Okay. Any questions?
Just one more branch will suffice.
Just the one, what's that?
Create just the one branch, not 2, 3, and divide all the works and then merge. Is okay?
No, you will. I haven't shown you the assignment yet. When the assignment has everything clearly laid out of like how
okay.
many commits,
Okay.
yeah, how many commits I want, how many. I can show you this. There's no problem because you can't do anything with this yet, anyways.
Okay.
Just let me add
All right.
this 1 sec. Just so people have this. Okay, so we'll get rid of this one. And there's the command. Okay, so the assignment looks like this. For you from a Git perspective, this is not the actual assignment in the programming perspective. So, and this is one of the few times that I'm like, here are points. Here's the point breakdown. So this is going to be done in conjunction with the other assignment that you're going to get later tonight. Create a new GitHub repository. 3 points for doing that. Make it private. Okay, 2 points for doing that. Add me and Zach as collaborators. I'll show you how to do that later. It's pretty easy. Okay, I've included our GitHub names, so you can add us really easily. Okay. You should have 8 commits for this assignment. Okay, the assignment's large enough. Okay, now, one of the things you might be doing is looking at this assignment later and be like, holy shit, this is really big for 20%. Yeah, that's fine, right? Think of it like it can be a big mistake and it's not going to hurt you too much, right? So it's not about the percentage. The lower percentage means great, it's not going to impact you as much. Merge commits do not count. So these commits where you're creating a branch and you're merging back in and it creates a commit, that doesn't count. So 8 commits. More is okay, less is not. They should be well spaced out and represent reasonable amounts of work, i.e. don't code all the way until Tuesday and then be like, oh, I forgot to commit. Because that doesn't count. And then you do 8 commits, yeah, 0 out of 16. Or 2 out of 16, okay? Each one, obviously, this is 16 points and there's 8, each one is 2 points. Ideally, tiny fractions of features. Remember, commit early, commit often. You will find breaking points where you're like, I'm gonna go get a coffee because I just completed this piece of work. Hey, commit. Each commit message should be thoughtful and attempt to define what the new code does, except for merge commits, 4 points. So each commit message is worth half of a point. So commits are worth 2 points, the commit message just a tiny bit. Just practice. Okay. You should create, check out, and merge. Check out, use, and merge 3 branches. So you need to branch 3 times. More is okay, less is not. Branches should represent larger entire features consisting of a few commits. I picked 3 because I can see 3 distinct pieces to this at least. More is okay, less is not. 12 points. All your changes should be pushed to your GitHub repository with a final push or commit no later than 3:15 p.m. on Tuesday. So you can do all your work and push it right at the end. That's fine. Or you can push along the way. I cannot tell when you push, okay? But I can tell when you commit. And when I look at them on Tuesday at 3:15, if it's not, I can't help you. But I will also assume that you're submitting your work in the other courses as if, so it's both. Okay, so there you have it. I think the breakdown is like 30 points, 28 points, something like that.
Quick question.
Yep.
So for the 3 branches you want us to create, like, do they all, how do I say, like, if I'm working on the master to some point and at that point I create 3 branches, or are they like, I create the first one, I worked on it for several commits, and then I create a second one based on the first branches?
No, most of the time they're off master. So it's going to be more like I branch off, I do some work, I merge it on, and that's like I'm done a certain portion of work. Now I'm going to start my second portion of work, branch off, right? Yeah.
Okay, I see. So they are like separated branches. So once I finish one, I merge it into master and then create a new one.
Yeah.
Okay.
Yeah. Yeah. So this forces you to think about your assignment in pieces, right? It forces you to think of your assignment in pieces. Piece 1, connect to the API, make sure everything's working. There we go, done. Done, branch. Next piece. Now I have everything working with the API, output stuff to the HTML. Or like it's piecewise. And that's good. I think that's an excellent way to be thinking about things too. Okay. So it kind of forces you to think a certain way. You will need to provide me with the URL in here. I will also be able to see it because you shared it. You added me as a collaborator, but I am also asking for the URL. Just it makes it easier to grade. Okay. Any questions?
I'm sure I will have a lot of questions while I'm doing it. So
yeah.
When would be a good time for, I don't know, just message you and see if you can.
Okay, so with respect to messaging me, you can message me anytime. I'm going to tell you though, my response time is going to go down. I've been feeling a little bit run down lately, just because there's been a lot of communication occurring outside of school hours. And I noticed that people are choosing not to do stuff during the day and instead choosing to do it at night. I'm here till 3:15 waiting for people to talk to me. If I'm going to have to say, if you're not really taking advantage of that, then you're risking no communication at all. Okay. So I'm going to take a little bit of a different stance because I am feeling a little bit run down now. I cannot guarantee a response at all. So message me whenever, but I do not guarantee a response. Okay. Ask me the question. I'll do what I can. I'll do what I feel like. But again, I need a little bit of a break. Yeah. So between now and 3:15, no problem. Absolutely here for you. Okay. After that, we'll see. Okay. Okay. All right. So, having said that, that's it. That's it for today until 2 o'clock, at which point we'll go over the solution, okay, for the exercise. So you've got a good 3 hours, 4 hours, plus or minus, including lunch, to finish up 3 hours, okay? And take a break. See if that thing that I talked about this morning helped. Otherwise, again, sorry, all the reading in here is with respect to the stuff that we just covered today. So you can rewatch the video, but if you're feeling like, I'm missing something, I want the documentation, or I want documentation about it, here is some documentation. And I always try to pick easy to follow documentation. Always try to. Easy to follow and complete. I like to have both of those. So take a look at this. Okay. And an exercise. Exercise number 8, pushing and pulling. It's just a list of like, go do this, go do that, go do that, to practice. Okay. All right, let's take a break and we'll come back in 3.5 hours. Sounds good? Okay, yeah. So see you at 2 o'clock. 2 o'clock, be here. I'll see you then.
Yeah, John.
Hey, John.
Yeah.
That's just 9, or does that say 8?
Exercise, it says exercise 8, should be 9. Yeah.
Cool.
Yeah. Thanks.
Hey, John, I messaged you something on Discord. Do you mind take a look at it?
Yeah, I'll take a look at it.
Yeah, thanks.